Welcome back. Let's work one last example of combustion. This one is a little bit of a different kind of problem. In this case, the flue gas has been analyzed. Okay, the flue gas contains 10% CO2, 5% CO, 5% SO2, and 80% N2 on a dry basis. There is no oxygen in the fuel, and we want to know what's the elemental composition of the fuel. So based on this, I can tell you that the fuel contained carbon, hydrogen, they always have hydrogen, and sulfur. So the fuel is going to be some sort of I don't know, what do we want to use? X, H, Y, S, Z, something like that. That's going to be our fuel. And what I'm trying to do is figure out what X, Y, and Z should be for this fuel, assuming that it all had some sort of homogeneous, like maybe coal or something might be like that. Okay, so the idea is I'm going to bring in this fuel. I'm going to bring in some air into my furnace. And I'm going to get out this dry stack gas. And I'm going to get out water. So how should we attack solving this problem? Well, since they gave us the composition of the dry gas, I'm going to assume as my basis that I have 100 moles of, dry flue gas. That means in the exit, let me just write a little quick material table here. I'm going to have CO2. I'm going to have CO. I'm going to have SO2. I'm going to have N2. Then I'm going to have also had some oxygen in there and this fuel, CXHYSZ. Okay? I also am going to create some water. It doesn't come in initially, but it will be there at the end. So the dry gas contains no O2, none of the fuel, and no water. The water contains nothing but water. We don't know how much. I'll just call it W. The air is going to be, no CO2, no CO, no SO2, there is N2. 79% of A, and the oxygen is going to be 21% of A. No fuel, no water. So it's going to add up to a total of A. This is going to add up to a total of W, this one to a total of W. And then I'm going to have my fuel. And it's going to be just the CXHYSZ, okay? And so I'm just going to call it F, okay? And the fuel contains nothing else but F, so I'll have a total of F. So I've created a material balance, or a material table. Now I need to start doing balances. And on reactions, especially if in this case, I don't even know what the fuel is, so writing a balanced combustion reaction would be very challenging. So let me just do an atom balance. Okay, now this is going to be a little different looking than what I normally do, but I can do this on any of these things. I have N I have C, I have H, and I have O, and I have S. Those are my atoms that I have. Nitrogen only comes in as nitrogen and leaves as nitrogen. So 0.79A times 2 is equal to 80 times 2. So I can solve that for A. A will be 101.3 moles. Okay? Now, let's start doing balances on these other things. So C. C comes in as the fuel, so it's X times however much of the feed comes in. There's no carbon that comes in with the air. It leaves as CO2, as CO, and that's it. Okay, so X times F is going to be 15. H, all right, so where's my H's? H is going to be Y times my feed, and it leaves as 2W. O, well, O is a little more complicated. It's 0.21A times 2, and it leaves in CO2, it leaves in CO, it leaves in SO2, and it leaves in water. And then finally I have my sulfur. Sulfur comes in only in the fuel, ZF, and it leaves only in SO2. So ZF is 5, XF is going to be 15. Okay. What else can I solve? Well, this one looks like it has two unknowns, but remember I now know A is 101.3. So I can use this to determine that W is equal to 7.53 moles. W is 0.53 moles, then 2W is going to be 15.1 moles. That's YF. I can now use the sum of X equation. So 15 plus 15.1 plus 5 is going to equal F. And now I can solve for the X, Y, and Z values. So it turns out that X is equal to 3, Y is equal to 3, and Z is equal to 1. So my fuel is C3H3S. This completes our instruction on Chapter 4. Probably you need to do a lot of practice at this stage. Our last lesson, our module for this unit is going to be just a review to prepare you for the midterm exam.